Welcome to the JuniorDev Canberra event. We are fully online for now, so just grab some snacks, relax, and enjoy the stream.
We would like to begin by acknowledging and celebrating the Ngunnawal and Ngambri peoples on whose land we meet and work. We wish to acknowledge their culture and the contribution they make to this region, and we pay our respects to their elders past, present, and future.
During the event, if you have any questions, please use the Slido link to post your questions, and our speakers will be happy to answer the questions at the end of their talk.
Hello everyone, my name is Andrea Parsons. So what I'm going to talk about today is beyond software development. I'm going to give a brief overview of some different ways of thinking, some concepts and some considerations. I started in IT about 40 years ago when people were coding COBOL and PL1. So my technical knowledge is very out of date. But in my 40-year career, I've covered a wide variety of IT roles. And I'm currently just doing some consulting and some teaching prior to getting ready for retirement. So the purpose of the presentation today is not to teach anything. It's about building some awareness. It's a brief overview, so I'm barely scratching the surface of the topics that I'm going to touch on. I'm going to work through some high-level concepts that stem from a course that I have been involved in teaching. Some of the topics I'm going to touch on I'm more knowledgeable on than others, and I'm going to give you some analogies to everyday life, because sometimes I think a simple analogy can provide quite a sound basis for developing a greater appreciation and awareness. So the purpose of the presentation is really just to start thinking about how you can increase your usefulness in a software engineering or a systems engineering team, and how you can improve the outcomes through an expanded understanding and appreciation. So what I want you to think about doing with this presentation is just giving it some consideration. If you're already instinctively doing some of the things I cover, then that's wonderful. Otherwise, perhaps you can use it to add some structure and guidance to your thinking, and to pursue some further knowledge in the areas that interest you. And hopefully some of the analogies that I give you will help you to think about applying the concepts I mentioned. So let's start by looking at some different ways of thinking. What you're, as software developers, probably already very good at is analytical thinking. So that's breaking something down into parts, thinking about the reason for each part, and thinking about how those parts must interact. The systems thinking and the behaviour thinking is something that is probably not so instinctive or familiar for you at this early stage. So systems thinking is thinking about the role of something in an environment, how it must fit in the environment, how it must respond in the environment, rather than what's going on internally. And the behaviour is how the interactions with the system are impacting on the system, how the behaviours impact on the system. So thinking about systems and behaviour tends to help put things into context. It surfaces more constraints and considerations, and it gives rise to more requirements, especially in the non-functional area. So if we think about the three different ways of thinking with an everyday analogy, just think about lasagna, as in the lasagna that you eat. So the analytical thinking for lasagna is the ingredients and the method, the breakdown of the components of the lasagna and how you're going to put it together. The system that it's working within is the menu, the part of the dinner that you're going to have the lasagna as a part of. So when you're looking at that sort of thing, you might have to give rise to thinking like, who might be vegan that's going to be eating this lasagna, or who might need gluten-free lasagna, or be allergic to dairy, or and thinking about what else is going to be served within that system, as in that particular dinner menu. because you wouldn't want to serve your lasagna with some steak, for instance, or something like that. And the patterns of behaviour are, how are your dinner guests going to behave on the night? And it comes down to perhaps thinking about, are you going to be serving your lasagna very late, in which case they're going to be extra hungry and they're going to need more serves of the food, or will they have had lots of drink before they've started on the meal, etc. So thinking about how the behaviour of the people involved in interacting with the system is going to impact that system. So that's three basic thoughts on ways of thinking. Another way of thinking is called design thinking. So this is quite a different approach to thinking, and it's very human-centric. It's a very creative approach, and it draws on some very diverse skills. So what this is not, what design thinking is not, is it's not a group of people sitting around designing some software. That's a little bit of a miscomprehension that tends to come up. It's a diverse group of perspectives. Those people who are impacted or impacting the system, and getting them together to contribute their needs, surface constraints, get ideas, etc. So on the slide that I'm showing here, we've got a sample process, and that sample process actually comes from a place called the Stanford D School. And in that sample process, there are 5 different process steps which you keep moving through. And the first one is to empathise, to get people together to actually kind of really get into the problem at hand, and then to sit and define it, to give it some more definition, so that you can ideate you can be creative and come up with ideas on how you're going to address a particular problem. You might prototype that and test it, and then keep going through the cycle to come up with some good design thinking outcome. So an analogy to think about here might be the design of a child's toy. If a group of adults sit down to design a child's toy, the chances are that the child's going to get more enjoyment out of the box it came in than actually out of the toy. So maybe by getting together a broad range of impacted people and influences around design for a child's toy, you can produce a much better outcome. For instance, you might have a parent there who will give lots of input about whether it's appropriate to have a noisy toy or things like that. You might have a child psychologist who can give you some really good information on the impact that different toys are going to have on a child. You might have a paediatrician who's looking at the safety of the toy, a legal advisor who's particularly focused on protecting children. You might have a teacher who's going to map how different sort of aspects of your toy are going to work into an educational curriculum. So each of the people in your design thinking team are going to contribute very different aspects and perspectives as you work through the process. So that's just another way of thinking. The next thing I want to talk about is the fact that we've got this difference between software versus systems here. So when you develop software, you're talking about developing some functionality, looking at sort of inputs being manipulated to produce some outputs. When you talk about a system, which is the thing that the software will belong into, you're talking about elements and interconnections and something with goals and purpose. And you can have systems within systems within systems, and some of those systems will be dynamic systems. So you have to keep expanding your thinking further and further out, so that you can surface these sort of further requirements and considerations from the system within which your software is going to run, and how other systems that sits in are going to impact it. So in the example that I've drawn up here, the software being built might be the student ID generator, which is something to generate student IDs. And it lives within a student management system, which lives within a school management system, which lives within an education system, which lives within the government systems, etc. So maybe as you write this software, you might need to reflect information about the fact that decisions have been made on higher education places, and that might impact the functionality you write to maintain and generate the student IDs. So maybe there's no impact at all, but how will you know unless you think about it? So we're sort of encouraging the thought to be done up front and in advance so that you won't be caught out. Maybe you might discover that there is some requirement to actually generate student IDs that reflect different course types as you generate them, and that things are going to change because of the things that are changing in the government systems there. So now let's just touch on a number of different sort of other considerations that are not ways of thinking, but sort of other concepts and things that you could have in your kind of toolbox as you work through the processes of developing software. And the first one is the unknown unknown. So we all have a big tendency to work within the known known, where we just know something, so we analyse it and we incorporate it in our software. Or the known unknown. So we know there's something we need to find out, so we go and investigate, we analyse and we incorporate it in our software. But the area that's really going to come back and bite people is the unknown unknown. We really need to pursue the unknown unknown, because that's when we start to expose a lot of complexity. It's very dangerous to ignore, and it's probably far more than you ever imagine exists in that unknown unknown space. So just as an example, I actually present a lecture where I draw up an initial understanding of a requirement that pretty much just has a couple of processes with a feed going between those processes. And that's what it looks like is needed from the sort of the starting point, the known known. But as I worked through the investigation into what I uncovered in the unknown unknown space, it basically ends up resulting in a highly complex diagram accommodating masses of information that was previously unknown, that would have severely limited the usefulness of what was being built if I hadn't surfaced that information. So really putting the effort into digging and delving and spanning out and extending and extrapolating, getting that big holistic view, a usage view, engaging with stakeholders before you start trying to incorporate things into your software so that you really know what needs to go in there. The next concept I wanted to go into was embracing complexity. So a lot of people go into software and systems development trying to make things simple. And that's a really nice thing to do, but sometimes simplicity isn't something you can achieve. It's about embracing the complexity and managing the complexity to generate a good outcome that's important. So this slide shows an example of a framework, which is not a process, it's just a guide to thinking and an approach to embracing complexity. So in this framework, basically, you're in the middle if you haven't actually assessed the situation. If you've got a situation that's simple or obvious, you're down in this bottom quadrant here, the obvious quadrant. So an example of a system there that sort of lives in that quadrant might be just issuing results to students after a set of exams. Up in the complicated quadrant, you might have something a bit more where you've got a lot of different practices that you could put into place, and you've got to make some decisions about the best out of those alternate solutions. So an example there might be moving to a new house. Lots of different ways you could do it. You've got to make a choice from the alternate solutions. If we go into the complex, this is where you're starting to have to experiment with solutions before you can decide on which one you want to start applying. And as you manage to narrow that down, you're probably going to move into the more complicated quadrant. And chaotic is more like an initial response to a bushfire, for instance. where you really have to act first and stabilise the situation, and then you might be in a position where you can start to apply some best practice and move through that perhaps complex into the possibly complicated framework. So when you look at this framework, the goal is to understand where you are with the situation at hand, and then to work in a continuous and dynamic way to move through the different quadrants in a clockwise direction to try and get as close to obvious as it makes sense to do, because it's likely to be the case a lot of the time where you're just not going to make it all the way to obvious. You're working within a complicated domain. Okay, the next concept I wanted to touch on is context. So what's context? It's tailoring the development processes for the type of project and the type of product that you're working on. So for example, you might have a commercial product, a piece of gaming software, where really the focus is on the functionality for uptake and profit of that piece of software. You might have something that you're doing for some sort of business administration purposes, such as a Medicare claim, where you've really got to be accurate. It's got to be providing some efficiencies to the users. It's got to be responsive. And you've got to look after some things like privacy and security of the users. But you might have something far more complex, like real-time defence type systems, like missile guidance, where the focus is on completely different things. It's on resource, the resource critical nature of the product, and the response critical nature, and the accuracy and the rigour that things have to work with. So looking at the different contexts that you're working in is very important to understand that there's different ways that you need to work through the process and different skills that you need to apply. But there's another consideration there, I think, and that is for the different contexts that you might be working in, you've got to decide whether the ethics and the morals around those contexts are things that you want to work with, that it's the area that you want to work with. So there is no point in going into a real-time defence type environment and being assigned to a project that's doing software for missile guidance if you really don't want to work in that sort of environment, if it's against your beliefs or whatever. So thinking about the sort of context for your software development is really important. It's a little bit of, as in terms of an analogy to real life, thinking about the way you dress for different occasions. So you dress very differently for a party than you would for a work meeting, than you would for going skiing. So, and to get involved in a particular context, you've got to have a desire to do so. It's got to be something that you're well suited to doing. Okay. The next one, it has a lot to do with context, but it extends this idea. When you're working with software development, you really need to be thinking about what standards apply. So lots of different standards exist. Some of these are to do with quality and building the trust of the people that are going to be using your software. So there's lots of places like the International Standards Organization, the IEEE standards, things like Open Web Platform. There's standards that might be internal to organisations. There might be formal standards versus informal standards. And those sorts of standards are all about complying with levels that have been predefined so that you can build trust in what you're building. The other type of standard here on the slide is around interoperability. So giving people confidence that if they take on your product, that it will interoperate in the correct manner within the environment that it's in. So examples there might be the HL7 standard for health messaging, for instance. So people know that if a product complies with the HL7 standard, then the messaging is going to be readable by other products in the health sector. TIA, Telecoms Industry Association. So you're using standards to ensure that a product is useful and optimized, that people can trust it, that they can have confidence in its interoperability. And what you want to do with standards is understand them up front, know what you're going to have to meet or what it makes sense to meet, so that you're not going down the track and then thinking, oh goodness, I've got to backtrack because I need to look at standards. And it basically just helps you produce much better outcomes. The next concept to touch on is human error. So this is a really interesting thing. You basically can't assume that people won't make mistakes. So I've had project teams that I've worked with where people have said, oh, but people won't do that. But you cannot make that assumption. You've got to consider all the types of human errors that could be made that will impact the operation of your product. So some three types of ways of addressing human error are shown on this slide. Firstly, the efficiency thoroughness trade-off. So an analogy here is me thinking about how long I should engage a housekeeper to clean my house each week. I could engage a housekeeper for many, many hours and they could do an incredibly thorough job, but it would cost me a lot of money. So I've got to decide, okay, I'm happy with 2 hours or 3 hours worth of work from a housekeeper, and I am happy to trade off the thoroughness. I know she won't get to all of the dust on the windowsills or the things that I'm happy to compromise on. So that's a very basic analogy for the efficiency thoroughness trade-off. The Swiss cheese model is where you are looking to put up a series of barriers to prevent harm. So a good analogy there, I think, is the current situation with COVID. You've got governments and health officers trying to put up this series of barriers to prevent harm. So the barriers might be things like recommendations to stay home, recommendations to stay 1.5 metres away from people, staying away from anyone that's coughing or sneezing, asking people to cough into an elbow, wearing a mask, isolating, quarantine, hospitals, intensive care, etc. So there's these series of barriers that are put in place that the idea is that they are unlikely to line up, and something is going to stop the problem from going right through all of the holes in the cheese and being something that's actually going to cause some sort of harm or some sort of loss. The third type of way of looking at human errors is basically just breaking it down into separating out. I'm looking for human error based on how the skills of the people that are going to be using the product or the software, the rules that they're using, or the knowledge associated with using it. So just basically breaking it down into different parts that the human errors could originate. So the last of the concepts that I wanted to touch on briefly is managing risks. So often when I'm working with young project teams, the first thing they want to talk about when they're trying to manage risk is, someone in my team might get sick, so that's a risk that I have to write up, or we might misunderstand the requirement. So I like to think about the fact that risks exist and they have to be managed, but we can separate it out into sort of 3 areas. The first one is that we really have to manage risk by simply behaving well, sort of behaving within the law, behaving within the guidelines, behaving by applying good practices. The second area is risks associated with uncertainty. So actually building uncertainty into plans, thinking about how uncertainty is going to impact things and making sure that you build it into the plans. And then defining and prioritising real risks, the things that beyond that sort of simple behaving well and managing uncertainty, but things that could occur that you really need to anticipate and decide how you're going to treat. The other thing about risks is that there are two types, and a lot of the time with the projects that are being run, the whole emphasis is on the project risks. What might happen in the course of executing this project that I might need to take care of. But a lot of people forget to think about the end product and the risks associated with that end product that they might need to anticipate and treat up front. So risk management is a process, and doing good risk management improves project outcomes. So if we look at an analogy, everybody is involved in managing risks every day. It's just something that you are doing all the time. And a driving analogy is what I like to use. So we manage some risk by behaving well. We drive on the right side of the road, as in the correct side of the road. We drive within speed limits, and we just behave well on the road. So we're managing risks that way. We're anticipating the uncertainties by doing things like saying, okay, it's wet weather, I'm going to allow a little bit of extra time so that I can arrive on time. Or maybe I've got to anticipate the fact that there's 10 different sets of traffic lights between me and my destination, so I have to anticipate the fact that they might all be red and allow extra time. And then there's sort of stepping up into the real risks around the fact there might be road accidents by somebody else doing the wrong thing and I can't control that. So behaviour of others, there might be roadworks that I haven't anticipated, etc. So a whole different sort of class of risks there. So in software development, you need to follow the standards and the guidelines to do a good job. You need to build uncertainty into schedules and commitments, and you need to manage real project and product risks. What I mean by manage is, not just identify them and put them in a table and say, right, I've done my risk management, but actually analysing those risks to decide how important it is to do something with them based on how likely they are to occur and what the impact of that risk occurring might be, and then deciding how you want to treat those risks. So you might decide that you can accept that risk, that you will just wait, see if it happens, and in that case you want to define what you're going to do if it is going to happen, if it happens, and have that ready to go. You might decide that it's not an acceptable risk and you need to mitigate it. You need to do something to either decrease the impact of it, decrease the likelihood of it, or actually eliminate that risk altogether, in which case, so you're mitigating that risk, which means you have to take some sort of action. So you actually have to then carry through that action and reassess the risk and decide whether there's any further mitigation, or if you've eliminated it completely, or if you've got an acceptable situation. So it is quite a process. And even once you've done your analysis and decided on those things and taken your actions, it needs to be monitored on an ongoing basis. So risks are something that should come up in every team meeting, every review of what you're doing, to make sure that you haven't found any new ones, or there's no change to the risks that you've got, that you've identified already. Okay, so just to finish up with this slide and explain why I think I'm telling you about these things, is to expand and enhance your opportunities as software developers. So the jobs that are out there increasingly need unique human skills like creativity and collaboration. The job shortage, on this slide, you'll see that coding, there is very little job shortage associated with coding. So job shortage is not coding skills, but we will need lots of people with better general digital literacies, including concepts touch on that I've touched on in this presentation. So being able to code is good, but we really need to focus on expanding people's skills, considering what's beyond software development and what directions that can take you. And by doing that, we're looking at increasing your usefulness to system and software engineering teams, and we're looking at improving outcomes through that holistic understanding and appreciation that has surfaced so much more than just what functionality needs to be developed. So I am going to end there, and I thank you for listening, and I do thank you for the opportunity that you've given me to present to you. And I will have a look and see if there's any questions coming in. Okay, I think we have one here that says, what are the most interesting things you learned from tech management and business roles? Are they different in different roles you had? I think that moving around different roles has been a fantastic experience, but having a technical background as the starting point for moving into management and business roles has been absolutely invaluable. So that's a starting point. I think that another point to make is that technology has changed enormously over time. So as I said, I started as a COBOL and PL1 programmer, and when I look at the programming languages and some of the technologies that are being used today, I'm completely lost. But there are some concepts around software development that just don't change, and the importance of really getting into these areas of solid requirements management and stakeholder engagement, and looking at all these different aspects and concepts, and having lots and lots of tools in your toolkit to bring out at the right time, and sort of learning enough to be able to apply the different tools in the right circumstances is really important. One here, have you been involved in a project you knew is not going to end well, and how did you convince people that it's not on the right track? I think that it's the answer to that question might be just continuously building credibility by basically working, as I said in a previous slide about behaving well, basically working with known and proven processes and guidelines so that you have those to back up any kind of explanations that you want to give people about the quality of what's going on and the chance of success of what's going on, and getting that reputation for being very open and honest about your projects and where they're at and where they're likely to end. Being known for someone who's not going to hide information from your superiors that you're going to expose and surface and try and actually attack and really work through the problems rather than trying to ignore them. I mean, one of the really important things here is that idea that you really want to expose and surface the complexity you've got to work with rather than ignoring it. And if you do a lot of that sort of work up front, you're just setting yourself on a much surer path for success than kind of getting stuck into something with this idea that I'll just start producing things and see how they work, and then finding that you've got a lot more complexity to deal with, a lot more non-functional requirements that are really architecturally significant in your development work that are going to throw you right off the track. Hopefully I've given some reasonable answers there. So it seems like there's a lot of unknown. Where do you see the technology in 10 years? What kind of industry roles, jobs would become popular or not as popular? I guess the emphasis there really is this last slide where they're basically saying, think carefully about all of the stuff that could be taken over by the computer eventually, and the stuff, and differentiate it from the stuff that really needs that human input, and that in-depth human analysis, and the digital literacy that they talk about, and the ability to interact with humans, because the machines really can't take that part of it away. So, making sure that you keep that sort of more holistic view, and incorporate the kind of the human side to software development as much as possible in everything you do, then I think you're setting yourself on a much better path than becoming very, very focused on coding. Do you have any books or articles to recommend on developing this broader view on software development and the tech industry? I absolutely do, and we should probably follow that up by supplying them through the convener of this meeting, rather than trying to list any here. After 40 years in the industry, what is something you wish you had known when you were a graduate? That's an interesting question. I'm not sure that there's anything that I wish I had known, because I have tackled my 40 years in the industry by allowing the industry to kind of drive the decisions I've made on where I go and what I do. And I guess I left the pure coding area quite early, and just kind of worked my way through lots and lots of different kind of IT roles, all of which I have to say I enjoyed. Worked for different companies. I've worked for government, worked for private industry. I guess, just basically being open-minded and always looking to learn is something that I think has probably been a really important part of my career. Okay, I will leave the call there then, and really appreciate your attention, and wish you all the best.
Thank you so much for coming, everyone. Here are the links for our Facebook, Meetup, and Slack channel.